Okay, Dan Old's here with, introduce yourself, John.
Hi, my name is John Lee. I'm the Vice President of Product Development for Appro.
Appro, very good. And this is kind of interesting. We talked about this at the GPU conference. I'm not sure you had one there, though.
We did have one there, yes.
Okay, I don't remember seeing it. This is the Tetra, right?
Tetra.
Tetra, sorry.
Not
Tetra.
a problem.
I think Tegra is a dandruff shampoo.
Well, actually, I think that's the term for the NVIDIA's integrated CPU. Integrated core. Tegra.
Oh, Tegra. Is it Tegra?
It's called
okay.
Tegra. They have a product called Tegra, and they have a product called Tesla.
That's right. Okay.
So we decided to be cute and call it Tetra to kind of give it some symmetry.
So what are we looking at here?
So what you're looking at here is a 1U Appro Tetra machine. Okay, and we call it Tetra because that's a play on a word meaning four.
Okay.
And we were able to fit in a very small 1U form factor 2P host with 4 GPUs. And I do mean 4 GPUs. So you got GPU number 1, number 2, number 3, number 4.
That's the thing.
Hosts.
I mean, you don't see GPUs any denser than that.
No. This is the densest platform that's available in the market today. And not only that, it still is. And not only that, it's extremely cool. It runs extremely cool. And
well, that was the next question.
Yeah. When I tell my customers that I fit 4 GPUs in a host, they say, "Hey, do you need a fire hydrant to keep this thing cool?" And we tell them we have intake fans and we have exhaust fans.
Well, some serious radiatoring there also.
Oh yeah,
right?
the heat sinks on this thing is pretty beefy. These are the M parts. These are the passive modules that NVIDIA makes available only to select ODMs who can develop custom platforms to be able to house their M modules.
Okay.
So we're one of the few ODMs that have a kind of a certified platform for NVIDIA M modules here.
Well, and you're one of the, you might be the only that's not, IBM, HP, Dell, the only non-major.
Well, actually, to be honest with you, NVIDIA has done a wonderful job. NVIDIA Fermi probably is one of the most incredible success story, I think, of 2010.
Yeah.
In fact, at this show, I think we found out top three out of the 5 most powerful supercomputers is Chinese supercomputer that's based on GPUs. And we kind of predicted that was going to happen at last year's supercomputing show, to be honest with you.
Now, the other thing that's interesting about this we were talking is that in this system, this trim, either Intel or AMD.
Mm-hmm. Right. We're host server agnostic. It really depends. Really, when customer is buying a GPU-based system, they're not as concerned about host as they are about buying the GPU power. Mm-hmm. Where the host does come into play is it really depends on how they're running the system.
Yeah.
What the AMD will give them is a lot more memory capacity.
Yeah. What
the Intel will give you is a better memory bandwidth.
Well, and that's the thing we were talking about, the bandwidth, is that Intel right now has leapfrogged them in memory bandwidth, but that's also bandwidth to the GPU as well, right?
That's correct.
So that's going to be a big deal in this.
Yes.
And it's going to be interesting to see what happens as they go on. You got magnet cores, double-head cores, but less memory bandwidth and less bandwidth to the GPUs. Well, now we were also talking about the idea that they don't use an awful lot of cores.
Right, absolutely. So with GPU applications, what they typically do is they like to lock a CPU core to a GPU socket. Mm-hmm. Okay, so even in our system, we have 4 GPUs, and we have 2 CPU sockets. However, each CPU socket holds 6 cores. So there's 12 CPU cores and 4 GPU sockets.
Yeah.
So really, the workhorse of the system is the 4 GPUs and 4 CPU cores. The other 8 cores, I'm sure they're doing other things, but they're not.
Could be.
Yeah, but they're not doing significant amount of work.
But we were talking, that's the programming model. That's the state of the art in programming now. That's going to change.
Yes, as we go, I think what we're finding out is, that's one of the reasons also why we're seeing this demand for higher ratio product. What I mean by higher ratio product is, this particular product was first of its kind in the sense that we had 1 CPU socket that was driving 2 GPUs. So we had a 2 GPU to 1 CPU ratio.
Yeah.
We're right now doing configurations where we have a single CPU socket to 4 GPUs. And we anticipate as the programming model gets better, that you're going to have even more GPU elements to a CPU.
But there has to be a limit to that. I would think that the I/O, the output coming from those GPUs and keeping them fed.
Right. Right now the limitation is the PCI Express Gen 2 bus. Okay. Next year when the Gen 3 bus becomes available, I think that bottleneck is going to get addressed. Right. So that would be one thing. The other thing also is the PCI Express. How many PCI Express device can a single instance of an operating system recognize?
Yeah.
Okay, so that also becomes an issue that you would need to address as well. But we're seeing this trend. We're seeing this trend towards those that are trying to leverage GPU technology to going into a higher leverage ratio, where you have a 1 to 2, 1 to 4, even 1 to 8, and beyond.
That's interesting. I would think that you'd be swamped by keeping it fed and by dealing with the results coming out of it.
Right.
But even a 1 to 8?
Yeah, then now you're actually right. Now, how do I get data in and out of that thing?
Yeah.
Right? So there's going to be more and more demand on having larger memory footprint, because it's faster for you to transfer data between the host memory to the GPU memory rather than going through the local media, whether SSDs or hard drives, right?
Just not enough to feed it. I mean,
Right. So that's where things like more memory channels with the Romley platform, faster memories come into play, and those things would add to the overall increased performance for a GPU platform.
What about, one of the things I've been thinking about for primarily enterprises doing some HPC is GPU as sort of a shared resource, like network attached compute.
Oh, okay. Well, that's actually the kind of concept that, God, what is that company? I can't remember right now. There's a company that did a PCI Express consolidation box. Next.io.
Yeah,
yes.
I saw them at the GPU thing.
Right, that's a different kind of concept, but it's a novel idea as well. And the whole idea of that is that you are separating the I/O element from your server box.
Yeah.
Okay, and then you have a 3U box where you can populate like 8 to 12 of these Fermi cards, or like
SSDs,
Fusion I/O cards,
or Mellanox,
like
or InfiniBand, whatever.
And that actually leads to a different conversation of using PCI Express as a bus.
It's a system interconnect.
More than what it was before.
Yeah.
It's actually becoming a system interconnect. You're right.
Which is interesting.
Which is very interesting, and which also is even more interesting when you realize when the next generation Intel architecture comes out, they actually bring the node bridge up to the CPU, so the CPU actually has the PCI Express Gen 3 lanes integrated into it. And you have a lot of Gen 3 I/O that's coming out of each of the CPUs. So it'll be kind of interesting what happens.
Times.
It is.
Very interesting
I think
times.
next year, in fact, I think you're going to hear a lot of people talking about the next generation products from both Intel and AMD, and you're still going to see a lot of people talking about GPUs with the big announcements.
Yeah.
For the top 500 as well.
Interesting stuff. Anything else we should know about this thing?
No,
Looks like we can go spinning disk. We can go
SSDs, right? I mean, the only thing that I would say is this is ready and available to ship, and it's actually quite affordable. Yes, we've been doing really well with them. We see very strong demand, and give it a try. We think this is a great platform for you to try out the GPU technology, because you only need this one box. We installed CUDA for you. It's ready to go. You just buy one, fire it up, and you're ready to go.
Get some on the truck out back.
No, but you can take this one.
Oh, really? You're going to sell that one?
Maybe.
You don't want to carry it home.
Maybe at the end of the show.
Yeah, when everybody's giving away their giveaways, right?
Right.
Good stuff. Well, thanks a lot, John. Really appreciate it.
Great. Thank you.
Bye-bye.